Hello, today we're going to learn about electric fields. So let's start introducing you the concept of fields, how to calculate an electric field, and go through an example. So what is a field? Well, a field is a way of conceptualizing and mapping the force that surrounds any object and acts on another object at a distance without apparent physical connection. Okay? So we have this force that acts on two objects, but there's no physical connection. There's no apparent physical connection. Okay? For example, the most famous example is the gravitational field. So we know that there's some forces that are pulling one object towards the other, and it depends on the mass of these two objects, but we cannot see any connections between these two forces. And so we say that between these two objects there's a field, and this field we have force that is inside this field. Okay, if you want to know more about how we represent the electric fields, you can take a look into the video about electric field lines. Alright, so the electric field, we can calculate the electric field as the ratio of the Coulomb force to a positive test charge Q. Okay, so we have the Coulomb force of this charge and our test charge. So for example, we want now to calculate the electric field from this particle Q here. This is a positive particle, and to calculate it, we know we have this test positive charge and the force that is associated with this this interaction between these two particles. Okay, so we have two positive charges, so the force will be in this direction. All right, and by the ratio of this force and this test charge, we say that's the electric field. Now, if you remember the Coulomb force, that's the formula for the Coulomb force from two particles that are interacting. Okay, so we have the constant, we have the force of the charges of the two particles, and down here we have the square distance. All right, let's add this force formula into the electric field formula now. So we'll have something like this, and if you notice, if you add the force here, we have a Q, a charge, our positive test charge up here, and also down here. So we can cancel them out, and we have this other formula for an electric field associated with a specific charge that you want to calculate. It does not depend on the test charge, the second charge here. It depends only on the charge you are interested. So the electric field is the constant K times the charge you want to know, the field associated, divided by the distance squared. Okay, let's go through an example now. So we want to find the direction and magnitude of an electric field that exerts a 4.8 times 10 to the negative 17 newtons westward force on an electron. And what magnitude and direction force does this field exert on a proton? Okay, so we first need to remember that the elementary charge is 1.6 times 10 to the negative 19 Coulomb. Okay, for letter A we're dealing with an electron, so that's why we have this negative here. Okay, So this is our example. We have the electron and a westward force. And we want to find the magnitude of the electric field. So we just add the force and the charge in this formula. We just add the values. We have the force and the charge of the electron, and we have that the magnitude of the electric field is negative 300 newtons per coulomb. Well, this negative sign here actually tells us that this field is pointing on the opposite direction of the force. All right. Now the same field in a proton. Well, we have the same values, but now we don't have this negative here anymore. So we have a force that's pointing the opposite way. It's the same magnitude, but pointing east. Okay. And that's the situation we have. We have the field pointing the same direction of the force. Okay, now it's your turn. So we have two charges placed on the x-axis, and the first with a charge of positive q is at the origin. The second with a charge of negative 2q is at x equals 1 meter. So where on the x-axis is the electric field equal to 0? And also, what magnitude and direction force does this field exert on a proton? So think about the situation here and write your answers in the comment section.
Thanks for watching. Don't forget to subscribe and turn on notifications to always get the newest videos straight to your feed.